What's up, guys? Welcome back. In today's video, we'll be creating a simple blockchain with Python. You know what? Let's get started. Now, before we actually start coding, we need to actually really understand what blockchain is and just really understand the whole concept of blockchain. So when we're actually coding, we'll understand what we're doing and why we're doing these things. And do not worry, I'm not going to make this complicated. I'll try to make it as simple as possible so you can understand it fully. Now we're going to use this analogy of a basic, simple cryptocurrency that for sure we just created here, and we'll call it CodeCoin. Now this CodeCoin has transactions, and transaction one could be basically that Toby sent 5 CC to Naomi. Now this is a simple transaction here. Toby sent 3 CodeCoin to Naomi. Then we can have another transaction, and this transaction 2 could be that Naomi sends 5.2 cc to, and we can have another transaction, and this is transaction 3, and it's James sends 0.5 because James is very stingy. He sends only 0.5 cold coin to Laura. We can see in transaction 3 that James sends 0.5 cold coin to Laura. Now what we can see right here is that these 3 transactions, they can be stored in a block. So therefore we could have a block, and we'll call this block 1. And since this block is the first block, this will be our initial block, or we can also call it the opening block. So therefore this block would give it a sign, or we could give it a name of opening. We say opening block. And this opening block would also take in our transaction. We'll take our transaction 1. It also take our transaction 2 and also transaction 3 and also transaction 3. Look guys, you can see that this opening block right here, it has all the information of these transactions. That's why we see right here transaction 1 to 3. And just so you know, an opening block or an initial block doesn't have previous. It's the beginning. It's the start basically. So it doesn't have previous hash informations. Now what can we do with this block right here? This opening block or this open block, we can hash it, and this hash will result in a certain transaction. Now what we can do with this block is that we can hash this block, and this block will result into a certain output. It will result into a certain hash output. Now you'll see that when we're coding, we'll use the SHA-256 function to get the hash. But for just this analogy, let's assume that we got a hash of this right here, and we got a hash of this value right here. Now, I hope you're following me. I hope you're with me, guys. This right here is the hash information of the first block. But then we actually open the second block, and our second block will also have transactions. Right here, our first block had all these transactions. Our second block could have transactions from 4 to 6. Now, guys, look, this block 2 right here will have information of transactions from, I'll just put it here. I won't put the transactions themselves, but I'll just put transaction 4 and transaction 5 and also transaction 6. Now guys, look, this transaction right here from transaction 4 to 6, you need to imagine that it has something similar like, oh, another person sent a certain Bitcoin to another person. So it's that whole structure, but just different persons and probably different amount. The information that this block right here will have, this block 2, it will also have the information, it will have the previous hash, and our previous hash in this case is our open hash. That's why when I explained the open hash, I said the whole point of the whole open hash is it doesn't have any previous information. It's the beginning, it's the initial, it's the first block. But anything after it will hold the previous information of the block that is linked to it. This hash, which is our previous hash, we'll enter it as the basis of this hash. So it's going to start like this. You'll see the hash, which is our opening hash. Then we'll have the transactions of our block 2, which is transaction 4 to 6. We have a block, which is our opening block, and this opening block has transactions 1 to 4. And then this opening block also has a hash, and this hash is unique to this opening block. Then when we create a block 2, the block 2 will have the hash of its previous, which is the opening block, and then it will have also the information of its block, which is the information of block 2. Now let's also say that, now let's say we have a function called samcodes hash. Now let's say we have a function called samcodes hash. Now let's say we have a function called samcodes hash. Now this analogy, now in this analogy right here, this explanation, I'm using samcodes hash as just a random hash function. But in our case, when we actually write a code, we'll use, as I said previously, we'll use SHA-256. And as I said previously, we'll use SHA-256. But in this case, I'm just using this samcodes hash as the hash function to explain the whole concept of this blockchain. And just so you know too, in this case, a real blockchain, or in a real Bitcoin kind of blockchain, it wouldn't be, oh, Toby sends 3 CC coin to Naomi. It would be, there would be more information, and it would be more structured in the way of the cryptocurrency. But this whole analogy is 100% how the whole blockchain works. But this whole analogy I'm explaining is 100% how a blockchain actually works. Now, what this Sam codes hash is going to do is going to take the string of this whole transaction. So right here, it will take the transaction strings. So right here, it will take the transaction string of Toby sends 3 CC coin to Naomi. You can see that Sam codes hash is taking the transaction 1, transaction 2, and also transaction 3 because it's our hash function. And then we also add to it the string opening block because to notify that this is the beginning of the block. And then, as I said earlier, we append all of them, we concatenate all this information, and then we get the result, which is this hash right here. We got this hash as our result when we calculated and concatenated all the information we had. Now, the cool thing is that the same thing right now, we have to do this for block 2, which is our second block. We'll take all the information, we'll take the transaction 4, transaction 5, and also transaction 6. But what we'll also add is the previous hash. And the previous hash is our opening hash. So we'll add that to our SAM codes hash. And we'll also get another unique hash out of that, which is unique to our block 2. Now look guys, let's say that the next hash is this right here. So we get another unique hash. So this is our next hash. This is the hash for block 2. And since we've gotten this right here, we'll create another block. We can do this on and on. This is block 3. And this block 3 will do the same exact thing that block 2 did. And this is why you can see that, and I'm sure you've noticed it right now, that this is very similar to a reverse linked list. Now, so this is why I said it's similar to a linked list, but it is not a linked list. This is a blockchain. And the whole point of it being a blockchain is that we have the previous hash inside the information of the next hash. So in this case, you see in block 2, we have the hash of our opening block. In block 3, we would have, in this case, let me just do it again. We have the information of this hash right here. We'll have that here in string format, of course. So put it in string format. And after that, we'll have the transaction. So that's the whole way it works. Now I'll leave a card above where I actually do Bitcoin mining, and in that video I explain blockchain in less detail than this, but what we talk about in that video too is how blockchain and how Bitcoin and all these cryptocurrencies are very good. And the good thing about them is, number one, they're not connected to any bank, and number two is that they're very safe and secure. They can't be hacked, they can't be used for fraud and all that. So why can it be used for fraud and all that? Because if one detail in this right here, maybe in transaction 2 right here, I change this from 2 to 1, everything changes. And the moment everything changes, we know that it's been compromised. And we know that the information right here is not the correct one. So that's why this blockchain is very important. Because the moment one information changes, one transaction changes, one digit in our hash changes, everything in the blockchain changes. And this makes it so great because if right now, as I've changed 5.1 to 5.2, this would be completely different. So this could be something like this. And then because this has been changed or been compromised, this too will change. And then this could be something else like this. And because this has changed, this right here too will change. So this right here will be, so this right here will be something like this. And because this has changed, this right here too will change. So you can see that one change, one little change will cause a radical change in the blockchain. Now, guys, hopefully you understood it and you actually understand the whole concept of blockchain. Now, let's actually build our own blockchain. Let's make our own blockchain. And we'll be using Python. We'll be using Hashlib, the module. I'll leave it down in the description below. I'll keep a link right there. You click on the link, you get to a web page where you just copy the command there and you paste it on your terminal right here. And when you paste it on your terminal, it's going to install Hashlib for you. And after that, you'll be able to get started with this whole project. Now, guys, look, let's build our own blockchain. Now, the first thing we need to do is we need to import hashlib. And this is what we're going to use for our hashing. So you import hashlib. And when you're done that, because we're going to use hashlib with SHA-256 to really get the hashes. So that's the whole purpose of installing or importing hashlib. And after that, what we're going to do next is we're going to create a class. I will call this class, we'll call this class CodeCoin. After creating a class, you know for sure you need to create a constructor for the class. And our constructor will say def underscore underscore in itself. And inside this in itself, after that we'll have our previous block hash. And we'll also have our transaction list. So these are the two things we will need. Then we'll just say self dot previous block hash is equal to previous block hash. And we do the same for transaction. Transaction list is equal to transaction list. Now that we've done this, we've created our class, we've created our constructor for our class. What we need to do next is we need to construct a data string using this sign right here as our separator. So this dash sign will be our separator. And the way we'll do that, we'll say self dot block data is equal to first our separator, and then we say dot join. Inside here we'll say transaction list. Then we say plus again our separator, and then we say plus again previous block hash. And then we do the same thing again but different. We'll say self dot block hash, because we did block data, now we need to do block hash, is equal to, now we're going to use our hashlib, the module we just did. We say hashlib does, and you can see we get SHA-256. So I'll just click on that. And after that, we'll say self dot block data dot, we need to encode it. And when we encode it, we need to do the hex digest to get the string form. So now we've done that. And this is all we need to do for this our class. But you see here in this comment, what do we need to do next? We need to actually create transactions. So we're just going to create some simple transaction. I have them in a notepad right here. So I'll just stick them right here to save a little bit of time. And I'll paste it right here. So you can see our first transaction says Toby sends 4 Bitcoin. Actually, I should change this to CC, which is cold coin. So say CC here too. Yeah, I think small letter is better. I'll just change this to small letter too. Say CC, CC, yeah, and CC here too. So you can see here we say Toby sends 4 cold coin to Ted, and then Emily sends 5.5 cold coin to Ted. Then Ted sends 2.7 cold coin to Sam. James sends 0.6 cold coin to Toby because James is really stingy, doesn't like sending money at all, only if he needs to. And then Ted sends 1.1 cold coin to Joanne, and also Ted sends 3.3 cold coin to James. So these are our list of transactions right now. Now, if we want to actually get the hash, we need to create an opening block or an initial block. Doesn't really matter what you call it, but the whole point of it is showing this is our starting, this is the beginning of our block right here. And we'll call code coin. And inside here, I'll put a string saying opening string. And after that, we'll use the square brackets and we'll say transaction 1 and transaction 2. So now that we've done that, now that we've actually created our opening block, what we need to do is we'll print opening block dot block data. And after that, we'll also print opening block dot block hash. I'll go to the terminal. In the terminal, we just say main.py, enter, and you can see right here, we get Toby sends 4 cold coin to Ted, and then we get this dash, this is our separator. Emily sends 5.5 cold coin to Ted, and then you can see that opening string. So you can see how it goes, and this is our hash. So let me just show you something. If I change this for this 5.5, I change it to 4 instead of 5, and we run it again, and just take a look at this hash right here. You will notice that it's going to be a completely different hash. So say.py. Now you can see we get a completely different hash. Completely different, nothing similar. Apart from the first letters that are both B, everything else is totally different. So even that is a big coincidence. So yeah, we can see that a small change causes a radical change in the hash and in the whole blockchain. So we can also do this for, now we can do this for the other transactions too. I'm just gonna put right here, copy it, paste it, but instead of opening block, I'll put second block. And right here, it's not gonna be opening string anymore. Right here, we're going to put opening block dot block hash. And here is going to be transaction 3 and 4. Now we print second block instead of opening block. And here too will be second block. We go to the terminal again. Main.py. Now look at what we have right here. It says Toby sends 4 cold coins to Ted. Emily sends 4.4 cold coin to Ted, and then opening string. And also we have Ted sends 2.7 cold coin to James. James sends 0.6 cold coin to Toby. And now you can see the hash that we get right here. And if you want to compare the hash that we have right here to this, you can see that we get exactly the same hash with our opening one. So this was the first hash we got. We got it right here, and that's how we got it. We said opening block dot block hash. So that's how we got it. And we can do this again. So I'll just do it one more time. We'll say this is third block, and here is going to be second instead of opening block. Transaction is going to be 5 and 6, and here we switch it up to third block. Okay, the third is a capital, so third block, and also here the same thing, third block. We run it again, and you can see what we get. We get this whole thing. We get the whole thing. We get Toby sends 4 cold coin to Emily. Emily sends. So we get our whole transaction so far. And you can see we get the individual hash for all of them. And you will notice that if I change one piece of information, it's going to cause a radical change in the hash. And that's how blockchains are used. And that's why they're so important. And this is how they enable Bitcoin and cryptocurrencies. So hopefully you enjoyed this tutorial. If you did, please leave a like, guys. Subscribe to the channel if you're new. I release content weekly. And yeah, guys, that's it for this tutorial. I'll catch you guys in the next video.